Hello, everyone. My name is Yitian Hao, and I'm going to introduce a paper published by Amazon in 2007. And the paper is named Dynamo, Amazon's highly available key value store. In this paper, Amazon published a system called Dynamo, which achieves two main goals: high availability and high scalability. So firstly, we are going to talk about why it wants to this goal, two of these goals. First, for scalability, as we all know that Amazon owns AWS, which is cloud services. So naturally, it wants high scalability to be one of the goals in developing a system like this. And secondly, since Amazon has its own e-business running online, then high availability is a key feature for its customers who wants to buy stuff in a website which react for a long time, right? And then so in our agenda today, we're going to talk about these two factors and also other design considerations. We also have a Q&A section. Now let's talk about high scalability first. So we're going to do some motivation for high scalability for sharding, but basically. So sharding is how we achieve for scalability in this case. Before we will have two replicas for the clients in a distributed system case. They will it will be fault tolerance because it has two replicas, but it doesn't necessarily mean high throughput if we store the data in both of the replicas. However, if we split the data in two of the replicas and also we have the copies, we will increase the through output because the client can talk to this replica for X and this replica for Y, the value of Y. So to increase through output, this is why we want sharding. But how do we split the data among shards? We can do it randomly. However, we can be hard to find the data if we do it randomly. We can do a key range. We can find it easily at this time, but it is hard for us to make it randomized. So, for example, we can have a replica which has a large amount of through output, but the other one is kind of silent. We can also do a key hashing. But at this time, we still, if we have one replica died, we still need a high cost to move the data from one to another. But how Amazon solved this problem? It basically come up with a technique called consistent hashing, which means it put all this data into one ring like this. Let's see this example. If we have a word called apple and its hash code is 22, we'll hash this value into M2, this replica machine. Similarly, if we have a word cookie whose hash code is 62, which corresponds to a position here, we can map this hash code to machine M1. Now, how about mortally scatter the data to make the data more scattered? Amazon creates something called virtual node, which is that we can virtually assume that machine M1 also locate at this, and this positions to achieve the goal of high availability. Next, let's talk about the feature of high availability. So how does Amazon solve this problem? It basically just ignore the strong consisting requirement and make Dynamo always writable and push the complexity of complex resolution to the reads. Let's see this vector clock diagram, which is adopted from the Dynamo paper. We can see that there is a conflict happen at this vector time. How does Dynamo solve it? It just retain both of the version and let the application to resolve this conflict. This always readable feature of Dynamo is can be observed from a customer point of view, because we can sometimes found our shopping cart contain bugs, which means our shopping cart may have some item that we have deleted reappear in the shopping cart. This is the kind of the bug expected in the Dynamo paper, but we are not angry about that because it's always writable. It gives customer the availability or the freedom to write things to the application. And we are going to also talk about other design considerations in Dynamo. The first one is how Dynamo handle temporary failures. And the technique is called hinted handoff. So let's see in this picture, if node A is temporarily down or unreachable, the replica normally lived in A will be sent to node D, let's say. With a hint in node A's replica metadata suggesting that this node is the hinted recipient of the replica. So that when A is back again, D will make an attempt to deliver the replica back to D. The other thing is how Amazon handle permanent failures, or more specifically, replica synchronization. How does the system knows that the two pieces of large data are the same, basically? How to make this synchronization? It uses something called a Merkle tree just to minimize the data transfer cost. So to compare two data, whether it's the same or not, it just need to send out the hash code over the network and compare the hash. We can see from this diagram that we have 4 pieces of data and we have 4 hash for each of them. We can add the hash of 1 and 2 and get a new hash, which is called A. And similarly got a new hash, which is called B. And we can also add A and B and compare and compute the hash of A plus B and got a hash of the entire tree. As long as we have good hashing algorithm, we can compare the data over the network in this small cost and achieve synchronization. And that concludes my presentation. We still have some time, so I'm going to post some discussion questions, which we can potentially talk over. My first question is, using DynamoDB, what is relational database? Can you think of an example of relational database? And DynamoDB, now a available feature at aws.com, is a famous example of non-relational database. Can you think of one example of a non-relational database and why we choose one over another? And my second question is, as we all know in relational database that we can have on multiple columns. So for example, we want to create a student database, we can have a student name, student ID, student major, and student contact information. We can have at least 4 columns. But DynamoDB is designed to only support key value store, which basically 2 columns. Why Dynamo support these design, but not more complicated storing type? My third question is, for those of whom who probably learned in distributed system course, there is a CAP theorem. And in this famous theorem of designing distributed system, which property does Dynamo sacrifice, and why does Amazon make this trade-off in just to fulfill its own requirement? So I have these 3 questions prepared, and I'm happy to start the discussion and welcome more questions if you have. If we do not have any other questions, that will end my presentation. And thank you all again for listening, and see you next time.